Welcome to the DIY Honda Garage channel. Welcome to the diagnostic session for DTC P0335, which pertains to the crankshaft position sensor no signal issue specifically for the Honda Accord models between 2012 and 2017. The crankshaft position CKP sensor is vital for engine performance as it monitors the injection and ignition timing for each cylinder and the overall engine speed. Any failure in this sensor can lead to a significant decrease in engine performance and can even prevent the engine from starting altogether. In essence, the CKP sensor translates the rotational position of the crankshaft into pulsing signals sent to the powertrain control module, or PCM, which is responsible for managing engine operations based on this data. The signal detection process occurs through a rotor that turns and enables changes in magnetic flux within a semiconductor. If the PCM does not receive these signals, it stores DTC P0335, indicating a malfunction. In conclusion, the crankshaft position sensor plays a crucial role in the overall timing and performance of the engine in the Honda Accord from 2012 to 2017. Any loss of signal from this sensor can quickly lead to DTC P0335 being registered, causing significant engine performance issues, including failure to start and stalling. By understanding the possible causes, symptoms, and troubleshooting steps associated with this DTC, technicians can effectively diagnose and resolve issues. Regular inspections and preventive maintenance practices can significantly mitigate the chances of encountering similar problems in the future. Implementing these practices ensures the continued reliability and performance of the vehicle. The crankshaft position sensor plays an integral role in the vehicle's ignition and injection timing. It is located near the engine crankshaft and consists of a rotor that spins with the crankshaft, along with a semiconductor that detects the rotor's position. When functioning properly, this sensor sends crucial data to the PCM to ensure that fuel is injected and ignited at the correct time. Hence, a malfunction can cause erratic engine behavior. If the CKP sensor fails or does not provide adequate feedback, the PCM may not be able to manage the engine effectively. This could lead to situations where the vehicle may not start, or it may experience stalling while running, among other complications. There are several potential causes that may lead to DTC P0335 being triggered. One of the more common issues is the complete failure of the CKP sensor, which would prevent any signals from being sent to the PCM. Additionally, a failure within the PCM internal circuit itself can also cause this DTC to register. Another possibility involves wiring issues. For example, the CKP sensor crank line might be open, leading to a lack of communication with the PCM. Moreover, a short to ground or an open circuit in the power supply line or ground line for the CKP sensor can also prevent proper operation. It's crucial to examine these aspects thoroughly during troubleshooting. Experience with DTC P0335 may reveal several symptoms that indicate a problem with the CKP sensor. One of the most prominent indicators is that the engine may fail to start entirely, leaving the driver in a precarious situation. Another noticeable symptom could be engine stalling during operation, which poses a safety risk if it occurs at high speeds or during critical driving moments. Additionally, you will likely see the check engine light illuminate on the dashboard, serving as an early warning that something is amiss under the hood. These symptoms are all linked back to the CKP sensor's inability to relay necessary engine timing information, affecting overall engine performance. For the first troubleshooting step, begin by inspecting the connections and wiring associated with the CKP sensor. Loose or corroded connectors can disrupt the electrical flow necessary for the sensor to function. Check the wiring for signs of damage or fraying, which can also lead to signal loss. It's essential that connections are secure and clean to ensure a good electrical interface. This step is foundational, since if the CKP sensor cannot communicate effectively with the PCM, it will trigger the DTC. Always reference the vehicle's service manual for specific wire colors and connector layouts to ensure accurate troubleshooting. In this second troubleshooting step, the emphasis should be on testing the output of the CKP sensor using a multimeter. This device will allow you to measure the electrical signals being sent from the sensor to the PCM. When the engine is cranking, the CKP sensor should produce a pulsing signal. If this signal is absent or inconsistent, it strongly indicates a malfunction within the sensor itself. Refer to the specifications for expected voltage and frequency of the signal to gauge performance accurately. Understanding how to read these measurements can help confirm whether the CKP sensor is indeed at fault. The third troubleshooting step involves verifying the functionality of the powertrain control module. Since the PCM is the component that interprets signals from the CKP sensor, any internal failures could lead to this DTC being thrown. To confirm the PCM is operating properly, check for any software updates that may need to be installed. Additionally, use diagnostic tools to run tests that can validate the software parameters stored in the PCM. If internal failures are confirmed, replacement or reprogramming of the PCM may be necessary to clear the DTC. After performing the necessary repairs, it's essential to carry out a final repair verification. Start by clearing the DTC from the PCM using a diagnostic tool. Next, conduct a test drive to allow the engine to cycle through all necessary operations and effectively validate that the CKP sensor is functioning correctly. During the drive, monitor for the re-illumination of the check engine light, which would indicate that the issue persists. Ensuring there are no outstanding symptoms after the test drive will confirm the effectiveness of your repairs and provide peace of mind to the vehicle owner. Preventive maintenance plays a vital role in avoiding the reoccurrence of DTC P0335 and similar issues. A regular inspection of the CKP sensor and its connections can help identify potential issues before they escalate into more significant problems. Cleaning and maintaining the connections will minimize the risk of electrical interference or oxidation that could lead to failures. Additionally, it's essential to routinely check the condition of all associated wiring to ensure that the insulation has not degraded or that no shorts are present. Such proactive steps can go a long way in preserving the reliability of the vehicle's engine management system. Please like and subscribe to the channel. See you next time!